Alg2 3.3. So the last time we met, we were talking about rational expressions, adding and subtracting. There's really nothing new today. We could skip this if you've mastered that, but this is just some extra time of us working with rational expressions, adding and subtracting. So again, what were the key steps? The key steps when you have fractions of any type that you are going to combine by addition and subtraction, you must have the same denominator. So when I look at 4x, the factors are what? That's 2 times 2 times x. And then when I look at 7, that is a prime number. So 7 is the only factor. So my common denominator here, or my least common multiple, is going to need a 2, an x, and a 7. It will need all of those things to be the common denominator. So this common denominator is going to be 28x. So I'm going to have 3 over 4x So in order to get the common denominator of 28x, this needs to be multiplied by 7 over 7. So you're always multiplying by 1 in the form of 7 over 7. That way you're not changing the fraction. Minus 1/7. And now I multiply by 1 in the form of 4x over 4x. So this will give me the same denominator, so I'm going to get 21 minus 4x, all of that divided by 28x. So that is the result. So again, it's looking at the denominators, being able to factor, finding common factors, and then performing the algebraic operation. So let's look at the next one here. So 1 over 3x squared minus 9x squared minus 12x. So a couple things to look at here. I've got 3x squared, but what is that 9x squared minus 12x? You've got to feel so lucky that we've already covered polynomials and factoring. So what can be factored out here? I can factor out a 3x, and I'm left with 3x minus 4. Okay, so that is 9x squared minus 12x. So it looks like if you look at the first expression has a 3x squared. So I've got to look at these two things here. These are my two denominators, and come up with a common denominator. So my denominator needs a 3x. Okay, it's also going to need a 3x minus 4. So that takes care of everything in this one, a 3x and a 3x minus 4. And the next denominator, it needs a 3x squared. Well, it already has a 3x. So to make that a 3x squared, I'm just going to have 3x squared. Okay, so the common denominator is 3x squared, 3x minus 4. So this becomes 1 over 3x squared. Now, to get the common denominator of 3x squared, 3x minus 4, this first term has to be multiplied by 1 in the form of 3x minus 4 over 3x minus 4. I didn't change anything, I just multiplied by 1 in a very specific form so that this becomes 3x squared, 3x minus 4. And then minus x over, and this common denominator is, you see it right here, this is 3x times 3x minus 4. So in order for this to be 3x squared, I'm going to have to multiply by x over x. So now you see both of the denominators are identical. It has to be 3x squared times 3x minus 4. So what do I end up with here? I get 3x minus 4 over 3x squared, 3x minus 4. That's my common denominator. And so then I get minus x squared. So let's just rewrite this, see if there's any simplification. This is minus x squared plus 3x minus 4 over 3x squared times 3x minus 4. Okay. I can think of this minus 3x squared plus 3x minus 4. That's the same as minus x squared minus 3x plus 4. And I asked myself, will that factor? Are there numbers that multiply to 4 and add to negative 3? Well, it's either negative 2 and negative 2, that won't work. Negative 1 and negative 4, that won't work. So this does not factor. So that is going to be my final answer. What are my exclusions? X cannot be 0, or x cannot be 4/3. Perform the indicated operations and simplify. So factoring is going to be a key here. So the first term I have x and if I look at x squared, so if I look at that first term, x squared minus x minus 12. So x squared minus x minus 12. Are there numbers that multiply to negative 12 and add to negative 1? So that's going to be a 4, negative 4, positive 3. So this is x minus 4, x plus 3, completely factored, plus 5. It looks like I can factor a 12, greatest common factor, x minus 4. Now I need to, before I do that, here they ask, find the exclusions. Well, the exclusions are x cannot be 4 or negative 3. Now to find my least common multiple, or my common denominator, it's going to have, look at each of the denominators. It's going to have an x minus 4 and an x plus 3. So x minus 4, x plus 3. Then look at the next denominator. I'm going to have a 12 and an x minus 4. I already have the x minus 4, so I just add a 12 to it. So this is my common denominator, or my least common multiple. So I've got to write this to where everything has that same denominator. So I'm going to have x over x minus 4, x plus 3. And in order to have the common denominator, this first term has to be multiplied by 1 in the form of 12 over 12. And then I've got plus 5 over 12 x minus 4. And then this has to be multiplied by 1 in the form of x plus 3 over x plus 3. Now, if you've done this right, you've got the same denominator, 12x minus 4x plus 3. 12x minus 4x plus 3. That is what I needed in order to add these things together and combine them. So I'm going to have 12x plus 5x plus 15, all of this over 12, x minus 4, x plus 3. So this becomes 17x that 12x plus 5 plus 5x, so 17x plus 15 over 12 x minus 4 x plus 3. Okay, so 17x plus 15 over 12x minus 4x plus 3. And one more and we are done, and then you have time to work on some extra practice here. So perform the indicated operation. So the key is always, can you factor this? So let's look and see. I've got x squared, so let's just come off here to the side. X squared plus 4x plus 4x plus 4. Okay, x squared plus 4x plus 4. Are there numbers that multiply to 4 and add to 4? Well, that's going to be a 2 and a 2. So this is x plus 2 times x plus 2. And then you look at the other term that you see, that is going to be x minus 2x plus 2. So what do we have here? We've got x plus 1 over x plus 2 times x plus 2 minus 6 over x minus 2 x plus 2. Okay, so that's completely factored. Now, what is your common denominator? So your common denominator is going to need 2 x plus 2's. So my common denominator is going to be x plus 2 squared. And my common denominator is going to need an x plus 2 and an x minus 2. Well, it already has an x plus 2. It's got 2 of them, but it's going to need an x minus 2. So everything has to be represented. So x minus 2. So that is my common denominator here. X plus 2 squared, x minus 2. So this becomes x plus 1 over x plus 2 squared. Now this is going to be need to be multiplied by x minus 2 over x minus 2 minus 6 over x minus 2 x plus 2 and this will need to be multiplied by x plus 2 over x plus 2. So what do I have here? So it looks like I've got x plus 1 times x minus 2, then minus 6 x plus 2. All of this is now divided by, check and see, the common denominator is x minus 2, x plus 2 squared. And then here, this is x minus 2, that's a plus, x plus 2 squared. Okay, so I've got that common denominator of x minus 2, x plus 2 squared. So when I do the multiplication that you see here, I'm going to get x squared and then minus x minus 2 minus 6x minus 12. That's the numerator. The denominator has not changed. X minus 2, x plus 2 squared. This is x squared. And it looks like minus 7x minus 14 over x minus 2, x plus 2 squared. Now we have to check and see, can this guy factor? Are there numbers that multiply to negative 14 and add to negative 7? So what are the factors of 14? 1 and 14, 2 and 7. So there's no way to combine those to get a negative 7. So this is our final answer. So x squared minus 7x minus 14 over x minus 2, x plus 2 squared, final answer here. And that should be it for this section. So again, nothing new today in 3.3 over what we did in 3.2. It's just additional practice of combining rational expressions. So the hardest thing here is not to make an algebra mistake and to just know we're doing these same processes every time. Find a common denominator, use that denominator to combine the fractions, combine the numerators, see if there's any simplification that can happen.